picture this.
Yeah.
Humanity not just visiting space, but like actually living there.
Wow.
Permanently.
Yeah.
Building homes on Mars,
Right.
harvesting resources from asteroids,
Uh-huh.
even turning the moon into a launch pad for deeper exploration.
I like it.
That's the future that your research dives into.
Yeah.
And let me tell you,
Yeah.
it's a wild ride.
It is a wild ride.
Welcome to Cosmos in a Pod Space and Astronomy series.
Yes.
Today, we're strapping in
Okay.
for a deep dive into space colonization.
All right.
Exploring the motivations, the locations,
Yeah.
the mind-blowing technology,
Mm.
and the hurdles that stand between us and a multiplanetary existence.
It's a good one.
It's a big one.
What I find fascinating is that your sources don't just treat this as like sci-fi fantasy.
Right.
They lay out a surprisingly pragmatic roadmap,
Okay.
starting with the fundamental question,
Yeah.
why bother leaving Earth at all?
Right, because despite all our problems, Earth is still pretty comfy
Uh-huh.
compared to, well, a barren rock in space.
Pretty much, yeah.
So what are these compelling reasons that your research highlights?
Well, the sources converge on a few key arguments.
Okay.
One that really stood out is the all our eggs in one basket problem.
Okay.
You know, Earth is vulnerable to asteroid impacts,
Yeah.
climate change,
Right.
even pandemics,
Right.
far worse than we've seen
Right.
colonizing space.
Yeah.
It isn't just about expansion, it's
Okay.
about the long-term survival of humanity.
So like a backup system.
Yeah, just in case things go
Yeah.
really south on Earth.
Right.
Kind of a sobering thought.
Right.
But I get the logic.
I get the logic too.
Yeah.
What else is driving this push beyond just safety?
Well, your sources also point to the incredible resource potential of space.
Okay.
We're talking about asteroids packed with rare metals,
Huh?
water ice on the moon and Mars that could be turned into fuel,
Okay.
and solar energy on a scale we can barely comprehend.
Right.
It's not just about surviving, it's about thriving.
Okay, so that's starting to paint a more exciting picture.
Little bit.
But isn't there also a simple human drive to explore?
Absolutely.
Like we climbed the highest mountains, sailed the vastest oceans.
Sure.
Isn't space the next logical step?
Several sources highlight the historical parallel.
Yeah.
Two explorers setting out for new lands.
Right.
Space colonization taps into that same spirit of discovery,
Yeah.
pushing the boundaries of what humanity is capable of.
Okay.
And this time, it's not just about claiming land.
Right.
It's about potentially terraforming entire planets.
Terraforming. Wow, that's next level.
That's next level.
But before we get too carried away with transforming planets, let's
Yeah.
figure out where we'd even set up camp.
Good point.
Your research seems to focus on a few key contenders for our first off-world homes.
Right. The sources lay out a sort of
Yeah.
cosmic real estate portfolio,
I like that.
each with its own appeal and challenges.
Okay, lay it on me.
The moon, of course, is the
Yeah.
closest and most familiar.
Yeah.
3 days away,
Okay.
potential water ice at the poles,
Right.
and it could be a great test bed for technologies before we venture further.
I can see the appeal of being close enough to Earth for somewhat regular visits.
Right.
But what about the downside?
Yeah,
Your research mentions some pretty harsh conditions on the lunar surface.
that's where the challenges come in.
Yeah.
No atmosphere to speak of.
Right.
Wild temperature swings between lunar day and night,
Uh-huh.
which last 14 Earth days each.
Oh, wow.
Building anything sustainable on the moon will require some serious innovation.
Yeah, I mean,
Curious.
14 days of darkness.
Yeah,
That's a long time.
it's a long time.
Okay, so maybe not the ideal vacation spot.
Yeah, maybe not yet.
But what about Mars?
Uh-huh.
It seems like everyone's talking about colonizing the red planet these days.
Right.
What's the appeal there?
Well, Mars is a fascinating prospect
Yeah.
because it offers the most Earth-like environment in our solar system. It has water ice, a thin atmosphere,
Uh-huh.
even some gravity,
Okay.
though only about 38% of Earth's.
Right.
Your sources suggest this makes it a prime candidate for terraforming,
Yeah.
potentially making it more habitable in the long run.
That sounds almost pleasant,
Yeah, relatively speaking.
relatively speaking.
Yeah.
But I bet there are some major drawbacks too, right?
Oh, for sure.
I mean, it's not exactly a short trip to Mars.
The travel time is a major hurdle.
Yeah.
6 to 9 months each way, using current technology.
Wow.
Exposes astronauts to prolonged radiation
Right.
and the psychological stress of confinement.
Right.
Plus, Mars has those infamous dust storms
Oh, yeah.
that could wreak havoc on any surface infrastructure.
So a bit of a fixer-upper planet.
It needs a little bit of work.
It needs some work.
Yeah.
But what about thinking outside the planet box entirely?
Yeah.
Your research also delves into the potential of space stations as colonization hubs.
Uh-huh.
Is that a serious contender?
Absolutely. Space stations offer some intriguing advantages.
Okay.
Imagine modular habitats like the Lunar Gateway,
Uh-huh.
but much larger,
Oh,
orbiting Earth,
yeah.
or even strategically placed near resource-rich asteroids.
I like it.
They could offer a more controlled environment,
Okay.
free from the constraints of a planet's surface.
Sounds pretty futuristic.
A little bit, yeah.
But I imagine even space stations come with their own set of headaches.
Oh, of course. The biggest challenge is resource dependency.
Okay.
Space stations would require constant resupply from Earth for the foreseeable future.
Right.
Think about it.
Yeah.
Food, water, air, spare parts.
Yeah.
Everything would need to be shipped from Earth,
Wow.
making it logistically and economically challenging,
Right.
at least initially.
Yeah. So maybe more of a stepping stone to full-blown colonization
I think so.
and a permanent solution.
Right.
Your sources also mentioned asteroids themselves as potential sites.
They do.
I'm picturing something out of The Expanse.
Oh, yeah, good show.
How realistic is that?
Well, asteroids are like the cosmic wild card,
Okay.
full of valuable minerals like platinum and nickel.
Uh-huh.
Some even contain water ice,
Right.
which could be converted into rocket fuel,
Okay.
turning them into refueling stations for deeper space exploration.
Right.
But building habitats on asteroids, that's where things get really tricky.
And I can imagine no gravity to speak of.
Right.
Constantly bombarded by micrometeoroids.
Uh-huh.
Not to mention the challenge of anchoring anything to a spinning rock in space.
That too.
Sounds like a recipe for disaster.
It's definitely not for the faint of heart.
No.
Your research highlights these immense engineering challenges.
Yeah.
But it also suggests that asteroids could become crucial resource hubs,
Okay.
even if permanent habitation remains a distant goal.
So we've got our potential locations.
We do.
Each with its own set of perks and problems.
Mhm.
But let's say we pick a spot and decide to go all in on space colonization.
Okay.
What kind of tech are we going to need to pull this off?
Yeah.
Because I'm guessing duct tape and a prayer won't cut it.
I don't think so.
No.
That's where the truly mind-blowing aspects of your research come in.
Right.
We're talking about a whole suite of technologies, some already in development,
Right.
others still in the realm of science fiction.
Yeah.
But one thing is clear.
Okay.
Life support systems are absolutely paramount.
Life support.
Yeah.
That sounds pretty basic.
Sure.
But I bet it gets complicated fast when you're talking about living in space.
Very fast.
What are the key ingredients for keeping humans alive off-world?
Well, the sources all emphasize closed-loop systems as the holy grail.
Okay.
Imagine a miniature Earth in a habitat
Mm-hmm.
where air, water, and waste are constantly recycled and regenerated.
Wow.
We can't afford to constantly ship supplies from Earth.
Right.
So learning to live off the land, so to speak, is essential.
So it's like creating a self-sustaining ecosystem in a bottle.
Pretty much, yeah.
Are there any examples of this kind of technology actually working?
One example that pops up in your research is NASA's MOXIE experiment,
Okay.
which stands for Mars Oxygen In Situ Resource Utilization Experiment.
Okay. I'm going to need you to break that down for me.
Basically, it's designed to extract oxygen from the Martian atmosphere,
Oh, okay.
a key step toward breathable air on another planet.
So we could potentially breathe Martian air one day.
Potentially, yeah.
That's pretty amazing.
It is.
But I imagine oxygen is just the tip of the iceberg when it comes to life support, right?
Exactly.
Yeah.
Your research highlights the interconnectedness of all these systems.
Mm-hmm.
Growing food, purifying water,
Right.
managing waste,
Yeah.
even creating artificial gravity.
Okay.
All of these elements will need to work together seamlessly
Wow.
to support human life in the long term.
It sounds like a massive undertaking.
It is, yeah.
But before we get into the nitty-gritty of space farming and waste recycling,
Sure.
there's another big concern I keep thinking about. Radiation. How do you protect colonists from those harmful cosmic rays and solar flares constantly bombarding space?
That's a crucial challenge.
Yeah.
And your sources explore several approaches.
Okay.
Shielding habitats with water, regolith,
Uh-huh.
or even polyethylene is a common theme.
Okay.
Imagine living inside a water tank
Okay.
or burying habitats underground
Right. Okay.
to protect against radiation.
Underground habitat.
Potentially, yeah.
So we might be living like mole people on Mars.
Maybe.
I'm not sure that's the glamorous space future I had in mind.
It might not be the most glamorous, but
But I guess safety first.
safety first.
What about the energy to power all of this?
Uh-huh.
Where are we going to get the juice to run these life support systems, habitats, and everything else a colony needs?
Well, your research consistently points to solar power as the most likely primary source, at least in the early stages.
Okay.
Giant solar arrays could harness the abundant energy of the sun,
Right.
particularly in areas with minimal atmosphere to filter it out.
Okay, that makes sense.
Yeah.
But what about places with long periods of darkness,
Mm-hmm.
like those 14-day lunar nights we talked about earlier?
Yeah.
Are we going to be sitting in the dark half the time?
That's where energy storage comes in. Advanced batteries, fuel cells, even potentially small-scale nuclear reactors are all on the table.
Wow.
The key is finding a reliable mix of energy sources to provide continuous power no matter where the colony is located.
Right, because nobody wants to live in a space colony with rolling blackouts.
No, definitely not.
Speaking of places to live, let's talk about those habitats themselves.
Okay.
Building anything in space is a challenge.
Uh-huh.
But these structures need to withstand extreme temperatures, radiation, and even the occasional micrometeoroid strike.
Yep.
How are we going to build structures that are both robust and comfortable?
That's where 3D printing comes in.
Okay.
Your research points to this technology as a game changer.
Right.
Imagine using robots to 3D print entire habitats out of local materials, like lunar regolith or Martian soil.
Yeah.
No need to haul heavy construction materials from Earth.
Right.
Just scoop up what's already there and start printing.
So we could be living in houses made of moon dust.
Essentially, yeah.
That's both futuristic and kind of poetic.
I think so, yeah.
But 3D printing takes time, right?
It does.
What if we need to deploy habitats quickly?
Yeah.
In an emergency situation?
For rapid deployment.
Yeah.
Inflatable habitats are another option.
Inflatable.
Yeah.
Okay.
These are basically giant high-tech balloons.
Oh.
That can be packed up small, launched into space, and then inflated on-site.
Okay.
Instant housing.
Okay, now we're talking.
Now we're talking.
It's starting to feel like we have the pieces in place to build a home in space.
It's starting to come together.
But there's one big question we haven't addressed yet.
What's that?
Transportation.
How
are we going to get all this stuff and all these people off Earth and out to these colonies in the first place?
Right.
Because right now, space travel is basically a billionaire's playground.
It is expensive, yeah. That's the elephant in the room.
Yeah.
And your research doesn't shy away from the immense cost and complexity of space transportation.
Right.
But it also highlights some exciting developments.
Okay.
Particularly in the area of reusable spacecraft.
Reusable spacecraft? That sounds familiar. Isn't that what companies like SpaceX are working on?
Exactly. SpaceX's Starship program is a prime example.
Okay.
Imagine a spacecraft that can take hundreds of people to Mars and back.
Wow.
Landing and relaunching like a giant space airplane.
Okay.
If successful.
Yeah.
It could dramatically reduce the cost per passenger, making space travel more accessible to a wider range of people.
That would be a game changer.
Big time.
But even with reusable spacecraft, those trips are still going to take months, if not longer.
Right.
Is there any hope for faster travel times in the future?
Possibly.
Okay.
Yeah.
I mean, who wants to spend half a year cooped up in a spaceship?
Right.
Eating freeze-dried food and staring out the window?
It's not the most exciting prospect.
No.
For shorter travel times, your research dives into some truly wild concepts like nuclear propulsion.
Nuclear propulsion.
Yeah. Now, this is still very much in the theoretical stage with all sorts of technical and safety hurdles to overcome.
Of course.
But the potential is there to significantly shorten travel times to Mars and beyond.
Okay.
Maybe even opening up the possibility of interstellar travel one day.
Whoa. Interstellar travel.
Oh, it's out there.
That's getting a bit ahead of ourselves, isn't it?
It might be.
We haven't even figured out how to live on Mars yet.
Right.
And now we're talking about visiting other star systems.
Baby steps.
I love your optimism.
Thank you.
But let's stay grounded for a moment and focus on the immediate challenge. Actually establishing a colony.
Sure.
How do we go from a few astronauts planting a flag to a thriving, self-sustaining society in space?
That's where things get really interesting.
Okay.
We'll need to delve into the step-by-step process of building a space colony.
Okay.
From sending robotic pioneers to establishing the first human outposts, and eventually to creating a new branch of civilization among the stars.
I like it.
But that's a conversation for part 2 of our deep dive.
You've definitely piqued my curiosity.
Good.
I can't wait to explore those next steps.
I can't wait either.
But for now, let's give our listeners a chance to digest all this amazing information.
Yeah, sounds good.
We'll be back soon with part 2 of our deep dive into space colonization.
I'm ready.
Where we'll tackle the challenges and triumphs of building a human future beyond Earth.
All right. Stay tuned.
Sounds good. Welcome back to Cosmos in a Pod.
We are back.
Last time, we left off with the tantalizing question of how we actually go.
From a few astronauts on Mars to a full-blown Martian colony.
Right, because planting a flag is one thing.
Yeah.
But building a society that can thrive for generations, that's a whole different level of challenge.
Definitely.
Your research seems to approach this like a multi-stage rocket.
Okay.
Starting with robots doing the heavy lifting.
That's a great analogy.
Yeah.
Several sources emphasize the importance of robotic precursors.
Okay.
These aren't just rovers squitting around.
Right.
We're talking about sophisticated AI-powered machines.
Oh, wow.
Capable of surveying potential sites, mining resources, and even starting construction of basic infrastructure before humans arrive.
So like an advanced team setting up camp before the settlers arrive.
Exactly.
Minimizing risk to humans.
Right.
And giving us a head start on building a habitable environment.
Yep.
But what happens once those robot pioneers have done their job? Is it just like humans arrive and move into their prefab space houses?
Not quite that simple.
Okay.
Your research suggests a more nuanced approach.
Okay.
Using the moon as a crucial stepping stone.
Oh, interesting.
Imagine a lunar base.
Okay.
Not just as a research outpost.
Yeah.
But as a full-scale testing ground.
Okay.
For the technologies and systems needed for long-term Martian colonization.
So we're talking about like a lunar proving ground.
Pretty much.
Where we work out the kinks in life support.
Yep.
Energy generation, food production. All those essential elements.
Exactly.
Before we try to replicate them on a much more distant and unforgiving planet like Mars.
It's a good strategy.
Yeah.
Much less risky.
It is a smart strategy.
Yeah. Yeah.
But I'm curious about those early Martian habitats. We're talking about underground bunkers?
I don't think so, no.
Or something a bit more, shall we say, aspirational.
Your sources paint a picture of modular habitats.
Okay.
Initially quite small and reliant on resupply from Earth.
Okay.
Think of them like interplanetary camping trips.
But gradually evolving into larger, more self-sufficient communities as local resource extraction and production ramp up.
So a gradual transition from camping to homesteading.
Yeah, I like that.
With Martian-grown food on the table.
Right.
And Martian-made tools in hand.
Yeah, exactly.
It's an inspiring vision.
Yeah.
But let's not sugarcoat things.
Sure.
There are some serious challenges to overcome.
For sure.
Starting with sustainability.
Yeah.
How long will it realistically take for these colonies to become truly self-sufficient?
Right.
Where they're no longer dependent on Earth for survival.
That's the million-dollar question.
It is.
And your sources offer a range of perspectives.
Okay.
Some optimistic, some more cautious.
Right.
The consensus seems to be that it will take decades.
Wow.
If not centuries.
Centuries.
Yeah.
To achieve true self-sufficiency.
Yeah. It's a long process.
That's a long time to be relying on care packages from Earth.
Yeah, it's a logistical challenge.
Yep.
And it's not just about the resources, right?
Yeah.
We're also talking about the human factor.
Absolutely.
How do we ensure the mental and physical well-being of people living in these isolated, confined environments generations removed from Earth?
That's where the psychological and physiological adaptation challenges come in.
Right.
Your research highlights the potential risks
Okay.
of long-duration space travel and off-world living,
Okay.
radiation exposure, bone density loss due to lower gravity, even the potential for unique Martian-borne diseases.
Wow.
These are all factors that will need to be addressed.
It makes you wonder, will future generations born on Mars even be able to visit Earth?
That's a good question.
Will they be too physiologically different?
Right.
Adapted to a lower gravity environment?
It's possible.
It's almost like we're talking about the evolution of a new human species.
It's a fascinating and somewhat unsettling thought experiment.
Your sources delve into the ethical and philosophical implications of this potential divergence, questioning what it means to be human, and whether our values and rights will translate to a multiplanetary society.
It's a big question.
It is a big question.
Yeah.
But before we get too lost in existential pondering,
sure,
there's a more immediate concern that keeps popping up in my mind.
Conflict.
Conflict.
Yeah. I'm thinking about all those sci-fi stories where Earth and its colonies end up at odds with each other.
Right.
Fighting over resources or independence.
Yeah, the classic us versus them scenario.
Exactly.
Yeah.
How realistic is that scenario?
Your research doesn't dismiss the potential for conflict.
Okay.
After all, human history is full of examples of
Yeah.
groups competing for power and resources.
It's true.
Yeah.
The question is, can we learn from those mistakes?
Right.
And create a framework for peaceful coexistence and cooperation in space?
That's the hope.
It is.
Yeah. So how do we prevent those sci-fi dystopias from becoming reality?
Right.
Is it as simple as drawing up some interplanetary treaties and hoping everyone plays by the rules?
It's definitely not that simple. Your research dives into the complexities of space governance. It's not just about legal frameworks, but about building trust, fostering communication, and establishing mechanisms for conflict resolution that work across planetary boundaries.
It sounds like we need a whole new field of diplomacy.
Yeah.
Something like interplanetary conflict mediators.
Right.
Shuttling between Earth and Mars to smooth things over.
Interesting.
Maybe we can train dolphins to do it.
Right.
They're supposed to be good communicators.
That's an interesting image.
Yeah.
Though I'm not sure how well dolphins would fare in space.
Probably not very well.
No.
But the point is well taken.
Yeah.
We need to start thinking seriously about how we manage relationships, resolve disputes, and ensure equitable access to resources.
Absolutely.
In a multi-planetary future.
Yeah, it's a whole new ball game.
It is a whole new ball game.
Yeah.
And I'm realizing this whole space colonization endeavor is about so much more than just building rockets and habitats.
Right.
It's about redefining our relationship with each other, with our planet, and with the cosmos itself.
That's a powerful insight.
Yeah.
Space exploration has a way of forcing us to confront fundamental questions about who we are, where we belong, and what kind of future we want to create. It's not just a technological challenge. It's a reflection of our values and aspirations.
I like that perspective.
Yeah.
It's not just about escaping Earth. It's about evolving as a species. About becoming something more than we are now.
I agree.
And I think that's an idea that can unite people from all walks of life, regardless of their background or beliefs. Space exploration has the potential to transcend our differences and inspire a new era of collaboration.
I hope so.
Innovation and hope.
Absolutely.
It's a reminder that we're all part of the same human story. And that story is just beginning to unfold.
That's a great place to pause for now.
It is.
Yeah.
But we're not done yet.
Right.
Next time on Cosmos in a Pod,
yes,
we'll wrap up our deep dive into space colonization.
We will.
By tackling those big ethical questions.
Okay.
The potential pitfalls. And the inspiring possibilities that lie ahead.
I'm looking forward to it.
Welcome back to Cosmos in a Pod.
We're back.
We've journeyed from the motivations for leaving Earth to the challenges of building a new home in space.
Right.
Now, in this final part, your research takes us beyond the nuts and bolts of rockets and habitats into the territory of ethics, philosophy, and the very soul of space colonization.
The big question.
The big questions.
It's where it gets really interesting.
It does.
What's striking is how your sources don't shy away from the tough questions.
Right.
They acknowledge that expanding into space isn't just a technological feat. It's a mirror reflecting our human values. Our potential for both greatness and folly.
It's easy to get caught up in the excitement of new frontiers.
Oh, yeah.
But we can't just repeat the mistakes of the past.
No, we've been there, done that.
So what are these ethical dilemmas that keep popping up in your research?
Well, one that looms large is the question of ownership. Who gets to claim a piece of Mars? Is it a first come, first served free-for-all? Your sources explore various approaches from strengthening international treaties to creating entirely new governance structures for a multiplanetary society.
Right, because the Outer Space Treaty, while a landmark achievement...
It was groundbreaking at the time.
It was written back when space travel was in its infancy.
Right. It could be outdated now.
It doesn't really address the complexities of permanent settlements, resource extraction, and all the potential conflicts that could arise.
Exactly. Some experts in your research argue for an updated treaty that clearly defines property rights, resource allocation, and environmental protection guidelines for celestial bodies.
Interesting.
Others propose a more radical shift.
Okay, like what?
A kind of interplanetary governing body.
Oh, wow.
That represents not just nations, but also the interests of future spaceborne generations.
It's almost like we need a cosmic constitution.
I like that.
Laying out the ground rules for a new era of human civilization.
It's a big task, but someone's got to do it.
But even with the best laws in place, there's still the issue of ensuring that this expansion into space benefits all of humanity, not just a select few.
That's where the concept of equity becomes crucial. Your research is full of cautionary tales about how space colonization could exacerbate existing inequalities if we're not careful. Imagine a future where only the wealthy elite can afford a one-way ticket to Mars, leaving the rest of humanity behind on a depleted Earth.
Yeah, that's not a good look.
Not a good look at all.
It's a dystopian scenario that we need to actively avoid.
For sure.
So how do we ensure that space exploration and its benefits are accessible to everyone, not just a privileged few?
Well, your sources highlight the need for global cooperation and investment in STEM education, particularly in developing countries.
So it's about creating opportunities for everyone.
Exactly.
To participate in this grand adventure.
That's the idea.
Regardless of their background or nationality.
Absolutely.
It's not just about who gets to go to space. It's about who gets to benefit from the technological advancements and scientific discoveries that come from pushing those boundaries.
Exactly. Space exploration has historically driven innovation in fields like medicine, materials science, and communications, with benefits rippling back to Earth. Imagine the potential for even greater breakthroughs as we establish a permanent human presence beyond our planet.
It's like a rising tide that lifts all boats.
I like that analogy.
But along with those exciting possibilities come some profound ethical considerations. About our impact on the environments we're entering. I'm thinking about things like planetary protection. Preserving the pristine beauty of these alien landscapes. Even the potential for terraforming.
That's where the conversation gets really interesting.
It does.
Your research delves into the debate between those who believe we have a moral obligation to leave these celestial bodies untouched and those who argue that terraforming is necessary to make them habitable for humans.
It's a tough one.
It is,
On the one hand, it feels almost sacrilegious to alter these ancient landscapes.
I get that.
On the other hand, if we can make Mars more Earth-like, wouldn't that open up incredible opportunities?
It would.
For human expansion and flourishing.
There's no easy answer.
No.
And your research reflects that complexity.
It's about finding a balance.
Exactly.
Between our desire to explore and expand and our responsibility to be stewards of the cosmos. To preserve the wonder and beauty of these alien worlds for future generations.
It's a delicate balance.
It's a reminder that space colonization isn't just about conquering new frontiers.
No.
It's about evolving as a species. About taking the best of humanity with us.
Absolutely.
As we venture into the unknown.
And that's what I find so compelling about the research you've compiled. It's not just a dry technical manual. It's a philosophical exploration of what it means to be human. In a cosmic context.
It challenges us to think bigger.
Yes.
To dream bolder, but also to act with wisdom and compassion.
Absolutely.
As we shape this multiplanetary future.
It's a powerful message.
It is.
And one that I think resonates deeply with our listeners.
We've covered a lot of ground in this deep dive into space colonization.
We have.
From the practical challenges of building habitats and growing food on Mars to the profound ethical questions about ownership, equity, and our responsibility to the cosmos.
Big topics.
Big topics. But as we wrap up this journey, I'm left with a sense of awe and excitement about the possibilities that lie ahead.
It's an incredible time to be alive.
It is.
To witness humanity on the cusp of a new era of exploration and discovery. And while there are certainly risks and challenges involved, the potential rewards are immense.
They are.
Imagine a future where we've not only established a sustainable presence beyond Earth, but also use that experience to solve some of our most pressing problems here at home.
It's a vision worth striving for.
Absolutely.
And who knows? Maybe one day we'll look back at this moment as the beginning of a new chapter in human history.
It's possible.
A chapter written not just on Earth, but among the stars.
I can't wait to see what that chapter holds.
And that's a wrap on our deep dive into space colonization.
It's been a good one.
A huge thank you to our expert for guiding us through this fascinating and complex topic.
It's been my pleasure.
And to our listeners.
Yes.
If you've enjoyed this exploration of the cosmos, be sure to follow Cosmos in a Pod.
Yes.
And subscribe to our YouTube channel.
Absolutely.
For more deep dives into the wonders of the universe.
We'll see you there.
Until next time, keep looking up
and
keep dreaming big.